A navigation question presents a little bit of a trickier situation than normal triangle trigonometry because the angles that you need are not entirely obvious, right? They're in this different coordinate system that involves bearings and south, north, etc. So what I'm going to do is point out what south of 54 degrees west is here. That's like you're going south, but then you curved your direction over to the west. Okay, so this would be south 54 degrees west because it's compared to the north-south line. Okay, so keep that in mind going forward. Now, take everything from those directions, jump over here into the picture with me. I've put everything into this diagram. We're hiking 5.4 miles south 54 west, and then going 3.6 miles south 15 degrees east. And what I want to point out is that this line right here is a transversal that cuts two vertical lines, the green and the black. And that transversal creates opposite angles. If you remember from geometry, that means this right here is 54 degrees. And we can do a similar trick in the lower case with those two parallel green lines to say that this right here is 15 degrees. We're going to need that going forward, and every one of these navigation problems involves you using a transversal somewhere to fill in some missing information. Now, if that 54-degree angle that I talked about first is there, we know this one must be supplementary to it, which makes it 126 degrees. And now if you look inside that triangle, I've got two angles right here, and those are going to add together to get my interior angle of the triangle. Okay, and that is going to be, let's see, what is that? 126 plus 15, that's going to be 141 degrees. Okay, so we can clean this up a little bit. So we have a nice diagram to look at right there. And that 141 degrees represents this angle. Okay, so moving back over here to our equation, which we can now finally use. This is a law of cosines problem because I have two sides, which I'll show you right here and here. Those are my two sides with the angle in between them. So let's just start plugging everything in. We get c squared, well, we don't know what c squared is, but a squared is going to be 5.4 squared, b squared is 3.6 squared, and then we keep on plugging those in, 5.4 and 3.6, and give it the big angle c, which is that 141 degrees, not radians, make sure your calculator is set up correctly, 141 degrees. And what that's going to give you, if you push through the math on your own, that'll give you 8.505 miles. Okay, so that's the distance back to camp. And I'll label that on our diagram over here. That's 8.505. Okay, step one's done. Now we have to find the bearing back to camp, which means we need to know another angle inside the triangle. I'm going to pick this guy right there. And we need a new law of cosines equation, which I'm going to set up as my angle A right here. So that's going to be a squared equals b squared plus c squared minus 2bc cosine A. I know what A, B, and C are, the little A, B, and C's anyway. So I'm going to have you do this on your own. Plug in A, B, and C. And what that's going to get you is the following. If you do your math carefully, for this problem, I got 0.9167 equals cosine A. And what that means is if you do inverse trigonometry, you're going to get 23.55 degrees equals A. Now that's not our answer. That's just the angle inside the triangle. So let's come on back over here. We'll put this guy in here and see what we can figure out for this diagram. So this is now 23.55 degrees. And you see that's not a bearing relative to north and south. A bearing relative to north and south is going to involve these two angles right here added together. So if you write it out this way, your bearing is going to be the sum of those two, which is going to be 38.5. We'll round that to 39 degrees. Okay, and I just have to be a little careful how I say this. That is 39, whoa, that's not what I wanted. That is 39 degrees relative to the north and swung east. Okay, so that's read as 8.505 miles, north 39, east. And you would just put those directly in here, like north 39 east and 8.5, well, we could round that, 8.5 miles or so.